evening one and all. The subject name is compiler design. Now in this subject we are going to discuss about some of the problems which are involved related to the parsing techniques. And what are the parser types? We know the different types of parser, that is LR parser, SLR, CLR, LALR parsers. Now we are going to solve various problems based on this parsing techniques. First, to implement this parsing techniques, that is a shift reduce parser or a simple LR parsers. Suppose if you want to prove that a grammar that is to be considered is LL1 or not. So for this type of examples, we have to consider first predict the function, that is first and follow functions. So this first and follow functions can be defined with the help of the rule such as first rule, if first of x equal to x, that means if the non-terminal which contains only one symbol, if that symbol is an epsilon, then what is the component that is available in first of x? So epsilon only. Suppose if it is a terminal only, that means that is here where if it is a terminal, then we are going to give that epsilon only, or if it is terminal only. If it is a variable x, suppose if that is a combination of several variables. Suppose if the production left hand side is only one non-terminal is available, right hand side it may contains epsilon individual thing, or it may contain a terminal, or it may also contain several non-terminals, list of non-terminals. So combination of terminals. So if it is a first one is, then we can consider this as a only. Whereas if it is a combination of the several non-terminals followed, that means y1 is one terminal, followed by y2 is another one, followed by y3 is another. So for this case, if we are going to check whether the epsilon is available in y1, any production y1 is available, then we are going to compute first is different, and if epsilon is not available in y1, that means suppose x equal to y1, y2, y3. y1 contains another epsilon or g. Like this, the productions may contain. So for these cases, if epsilon, suppose if y1 contains, y1 derives sub bc, but here y1 does not contain epsilon. So for this case, if epsilon does not belongs, then we have to consider first of y1 only. That means whatever the result that is displayed, first of y1. Whereas if the production y1 is also contain epsilon, then we have to exclude epsilon for the first of y1 plus also include first of y2. These two remaining two also we have to include. Then after that, if you include first of y2, y3, then you have to calculate y2, y3 also. Then in the case of y2, y3, if y2, once again, if y2 is does not contain, then y2 only. Suppose if it belongs to y2, the epsilon belongs to y2, then we have to exclude epsilon and have to write first of y3. So here y3 only left. Still any y4, y5 is there, then we have to calculate that one also. So that is how the first is to be computed, and the follow is to be computed with the set of rules such as first rule is A derives alpha B. So here what is the follow of B? We are going to find where the symbol appears on the left hand side only for calculating the first, and whereas for the follow, where the non-terminal appears on the right hand side of the production. So here we are going to calculate B. So we have to verify where the B appears on the RHS of this production. So B appears here. So what is this follow of B? It indicates that the follow of E. It is the rule indicating that what is the follow of B, what is the follow of A which we calculated, which is equal to follow of E. If it is already calculated, okay, else we have to calculate. And another production, A derives alpha B followed by beta. So here previously after B there is no symbols available, but after B here we have to, while calculating B, follow of B, we have to verify whether the beta exists with epsilon or not epsilon. Suppose if epsilon does not belongs inside the beta, then then we have to consider first of B, follow of B equal to first of beta. Else if epsilon belongs, if it is available, then we have to consider first of beta excluding epsilon followed by follow of A. So these are the main requirements for computation of first and follow. So based on this rules only, we are going to verify whether the grammar is LL1 or L or not. Parsing table implementation. So let us say, for example, in this we have take one production, S derives this much, and B derives C, and BC epsilon, EF, G epsilon, F epsilon. So for these productions, we are going to compute first of the functions and follow of the functions. So first of the functions can be calculated with the non-terminals which are available on the left hand side only. So here S is available, so that's why we have computed first of S. And what is the first symbol most applied here? It is A. So if it is not terminal, then we have to directly include, we have to use. So based on the previous rule, if it is a terminal appears A, that means small a, then we have to include that one as a first of S. And first of B also similarly we can calculate with what is the first that is available for this right hand side, C. So we have to include C. Whereas first of capital C, here also B. But here the production is to be contains two productions. Why? Because it contains slash. So C derives small b, capital C. It also contains C derives epsilon. These two also contains two productions. E derives G followed by E derives epsilon. Then F derives, capital F derives small f, capital F derives epsilon. So these two carries this production and these two carry this production. So if you observe this one, the first of C, in this case, what is the, so that's why here first one is B, followed by another production also which contains epsilon. So according to the rule, if any production rule derives X derives epsilon, then we have to include epsilon for the first computation. So that's why I have included epsilon in the first. Why? Because here the C derives epsilon. Then that is we are not going to see after epsilon or before epsilon. So it is the first epsilon we have considered. And whereas here first of D. So here if you consider the first of D in this production, what is the symbols that is available? Capital E is one terminal and non-terminal, and F is one non-terminal. So we have to make sure that first of E minus, why? Because first of E contains epsilon or not, we have to verify. So in this example previously you see, here the X, Y1, Y2 case, Y1, Y2, Y3. If Y2 does not contain epsilon, then we are directly implement first. Whereas it includes epsilon. So in this case, then we have to apply first of this excluding epsilon union followed by that one. So here that's why first of it contains epsilon. So first of E minus epsilon followed by first of F. So what is first of E? We have not calculated. We can calculate what is first of E here. It is small g comma epsilon. Whereas first of F is small f epsilon. So now we have to include this. What is the first of E? G comma epsilon minus epsilon union first of F. What is F? F comma epsilon. So what it contains? G comma G union F epsilon. So what is the union of this one? F comma G comma epsilon. So that is the same result to be F comma G comma epsilon. And whereas follow functions, we apply this dollar. Why? Because at the initial, so here if the start symbol is yes, that means root node which is the first and foremost then we have to include dollar for this product or this one. So that's why S is the start symbol, so we have to include dollar. The remaining. So what is the follow of S means? Here we have to verify where S appears on the right hand side of the productions, where S appears on this one. So here right hand side there is no S in this case, here. So that's why you have to include dollar only. Any other appearance was there, then we have to calculate that one. Suppose for example second one, follow of B, where your B appears here. So here B appears here, and second, third, fourth, remaining all cases B doesn't appear. So here follow of B is to be denoted with follow. That means here next one is a non-terminal. So that's why here first of D minus epsilon. So if D contains epsilon, no. If D does not belong to epsilon, then exclude epsilon followed by first of H. So first of D is already calculated, that is G comma F comma epsilon minus epsilon union. What is first of H? First of H calculated previously. So first of S, A, B, C is there. So what is this one? In this case, small h. So small h only. So that's why we are going to include h. So F comma G, epsilon is excluded. F comma G comma H. Whereas follow of C. What is C here? C not we are not going to see the left hand side, right hand side only. Here one production is there, capital C. Another production is there, capital C. So follow of D, which is this one, and this one is follow of C only. So follow of C equal to follow of C, which is the same result. So that's why follow of B, where we have calculated already previously, follow of B. So same result which is included for follow of C also. And for D, where is D appearance? Here D appeared at this place, first production. And in the remaining productions, capital D is not available. So what is the follow of D here in this case? The first of H is to be considered. So what is first of H? H only. And for the E is not available, first production not available, third is not available, but in this production, capital E is available. So what is the follow of E in this one? Follow of E is first of F. See here, F is contain epsilon. So that is to be verified. Previously, the follow of this one, there is no epsilon, but here epsilon is included, epsilon is available, so we have to exclude it. So in order to exclude it, first of F minus epsilon union follow of D. So that's why first of F already we calculated, F comma epsilon minus epsilon union follow of D. Follow of D is already calculated H. So these two things combined you can write as F comma H. So that is the result, F comma H. Whereas follow of F, which is equal to small capital F. Capital F, where it is here the production which contain this. So which is as follow of D. Follow of D. What is follow of D? Already we calculated H. So that is to be equated as follow of H. So based on the rules which is available with the first and follow computation, simply we apply the rule and we make these computations. And after making this computation, we have to list out the corresponding entities with the table and row banner. So this table is called as parsing table. This table is called as parsing table. Parsing table we can write with rows and columns, where set of rows, row wise, all the non-terminals which are available in the description of the given grammar. And what are the operators? That is to be written as column wise notation. That is identifiers, operators, all this to be written as to be. So for this, in this example, what are the non-terminals that are available as the left hand side of this expression? Capital E, E dash T, T dash F. So we are going to write this one, capital E, E dash T, T dash F. And whereas in the right, that is in the row wise. Whereas in the column wise, we have to represent the operator notation is the one plus operator, star, left parenthesis, right parenthesis, and we have to include one dollar also, that is representing the end of the string, and ID. So these are the remaining symbols. We are not, that is already counted with the non-terminals only. So inputs and then non-terminals. So that is to be written with the table, and for each entity, that is for each row and the corresponding column where match occurs. Suppose for example non-terminal E and this ID. Then we have to write this entity, the corresponding ID plus star, left parenthesis, right parenthesis, dollar. For example, if we calculated the first of E, which is equal to first of T. What is first of capital T? First of F. What is F? Left parenthesis, ED. So this is the result of this one. So we are going to write this computation where this left parenthesis and ID. Left parenthesis ID, two places appear this first of E expression. So on the horizontal row, first row E, where the appearance of this left parenthesis, so we have to write this expression, this derivation. So this derivation E dash T dash should be written as a row wise with the corresponding symbols appeared in the calculation of first functions and follow first functions. So that is E dash T dash. So ID is one, first one is capital right parenthesis and second one is ID. So both the cases we have represented this one. And for the E dash also we are going to observe the functions for the given grammar. We are going to get this plus E dash, we are going to plus followed by right parenthesis and dollar. So we are going to write this E dash, E dash with the string derivation for this. And for the T and T dash F also can be written with the similar manner. That means in the previous example where we have written, that is S, B, C, D, E, F. That is one row, and column wise we are going to write this various operators that is to be written. That is, here there is operators you may use, but in this example it is not given. So that depends on the grammar symbols we are going to be represented. So here to verification purpose we may consider all the symbols. Suppose if that input is not able to process, that means epsilon is there, then we have to consider the follow of the computation. So for example in this one, like this, after making the entries, verify any cell which contains more than one entry. Verify any cell which contains more than one entry. So if the duplicate, if any cell exists more than one, then that is not as a LL1 grammar. So the grammar is to be considered with the plain grammar without repetition. So here in this grammar, if you observe the terminals, that is non-terminals, and the inputs applied, that is A, B, E, I, T, S variables. Variables is rows and columns terminals, where here the S derives A and one more. And here see here the production rules are to be supplied with two entries in the corresponding cell S dash derives E. So for this we can say that it is not, grammar does not belong to one. So there is overlapping occurs where more than one entry. In the previous example, here there is no more than one entry available. So here for example if you see ID, only one entry, left parenthesis, plus. For the third row also only one entries. For the fourth row T dash also, which contains plus star parenthesis dollar. And for capital F it is also ID and right parenthesis. There is only one entry we define. Depends on the example of the grammar given. But for this example in this grammar where we have calculated first of S, we have calculated first of S and first of E. So what is first of S here? Small I. small I, comma A. So what is first of E here? First of E is B. And first of S dash. So if S dash is there, we can we can obtain the grammar with the S dash E dollar. So we can write this expression with the first of I followed by this one also I and this one also E. So that's why I comma A is to be written. So if more than entries are there, then we can say that the grammar is not excellent. And the calculation of follow depends on the computations of the derivations where the more than one, that is which is not possible with this one. Suppose for example here E dash dash plus T dash and the plus followed by plus, what is the computation that is to be supplied for first of E dash. So here plus of E dash is plus and then epsilon, lambda or epsilon both are same. So that's why here we have to write, we can also write lambda or epsilon. So this is the E dash, first of E dash plus right parenthesis, first comma right parenthesis dollar. So here epsilon is there. So that's why if any epsilon is there, so for this case, first we have considered epsilon completed, and for epsilon entries, we have to make sure that follow of E dash, follow of E dash. So follow of E dash, where E dash is available, that is here E dash is available here. So follow of E. What is follow of E? Follow of E is plus right parenthesis dollar. Follow of E is right parenthesis and dollar. The follow of F, first of F. What is first of F? First of F is right parenthesis ID. So that's why here right parenthesis dollar, that is to be included. So first of E contains dollar. Follow of E is equal to dollars. Now we are going to calculate E dash. E dash is follow of E dash. Now here E dash appears that two times. This time first production and the second production also. So for E and E dash. So follow of E only. Follow of E means dollar. Dollar, that is to be included. So that's why here dollar is to be included. And right parenthesis ID is determined with follow of plus first of E dash. E dash is plus. So then epsilon is epsilon with the parenthesis and dollar. So T is first of F. What is first of F? First of F equal to left parenthesis ID. Why? Because this is the first of F. Now first right parenthesis ID. So here T is ID. So ID left parenthesis. These two are to be. So like this we are going to compute all the first and follow functions for different, and to make sure that whether the entries are to be based on the rules given by the first and follow, and then form the table, Parser table with the rows and columns. If the corresponding entries defined are more than one, verify that one based on the given grammar. If multiple entries are supplied, then we can, based on that, it is not. In this example, this derivation supplies after that one multiple entries are defined, so it is not one. But in this example, E dash T dash, where the entries are not marked with multiple, only single entries are available, so that's why it is belongs to an LL1. So these are the one of the topic which is available. Next we will come up with one more thing that is to be available, that is LR parsers, LR parsers, and another problem solving with that type of procedure notation with the different types of parsers. All the contents which are available from this book, and we will come up with the next class with the new topic with the more problem solving techniques. Thank you, Ananda.
Like, share and subscribe. Hit the bell icon for more updates.